So Buggy wants to join Fang, and the fun fact is Buggy don't even know what the stack is. No worries, Buggy. So basically, stack is very simple linear abstract data structure where whatever last element we added that get removed first. So stack follow last in first out principle. Let us understand this through one simple diagram. So if you see in this diagram, we are having one jar and we are putting balls into this. So here we have only one opening, and whatever element or ball you added last, that only you can remove first. If you ask me a real life example for this, the very simple and daily usage example is that undo functionality in text editor or browser. So whatever changes you are doing, that is getting added into stack frame, and when you do undo, this change, the last change that you did, that get removed from the stack frame. And that's it. If you see the code wise, we have two options to implement the stack. One, we can use arrays, and the second, we can use linked list. So let us see both the codes. Here I have created one empty console application. If you see the code, there is nothing. I'll remove this also, completely empty. So I will take one array to store the data that user want to store. I will make it private, and we will store int into this. And we will take one variable to maintain the top. So what is top? In stack, whatever new elements we are storing, that element get identified with the top. So in this diagram, if you see, if I add one element into this, the top pointer will point to that element. If I add second element, the top pointer will go up, and now it will point to the last added element. And this is how we got to know this is the last added element, and we can remove that one. So just to identify that, we are taking one top variable. This will also I'll make private, and initially I am making it the -1 because there is no data to point, right? And when user will create object of stack, we will ask him size also, because this is arrays, and in array we need to provide size initially only. So for that reason we will ask size, and we will give default 10 because if user didn't provide, we will create array of size 10. Let us assign this. By the way, this is primary constructor that C# is providing since .NET 8. In stack, we have basic operations. One is add the element, second one is remove the element, and third one, see what is the top element, the last added element. So there we are not removing that element. We are just checking what top data we are having. So when we want to add any data into stack, we call push method. So this is the terminology that we use in stack. Push to remove pop, and to see the data, we use pick. So for push, it is it will not return anything, and just to make things simple, we will take size also. This will help us to easily get to know is our array full or not. I'll give the name count small c only, and initially this will be 0. So when user will come to add the data, first we will see are we even having space available to add that. So we will check that against size stack overflow exception. Perfect. Otherwise we will add the data. So when we will add the data, we will also increase our top, because as the more and more data we will add, our top should get pointed to the recently added element. So for that reason we will change top. So what we will do here, we will use pre-increment. If you don't know what is this pre-increment, so because first time our top is pointing to -1, first it will make that to 0. It will do plus plus, and after that on that 0th index our new data will get added like this. And we will do same for count also. Here it doesn't matter you do pre-increment or post-increment, because we don't have any operation or dependency immediately on this variable, whereas on this top we have dependency immediately. If I did post-increment like this, it will not work, because first he will give -1 index, you can say, to this data to add the value, and after that he will increase the value of top. That will, so, and that will not work because -1 index we don't have in arrays. It will throw exception. So that's why first we are increasing the value, and then we are accessing array based on that index. Got it? Very simple. And push is done. This is the only thing we have in push. If you ask me pop how to implement that, very simple guys. We will return int, because whatever element we are popping, we have to return that also, and we are not taking anything because here we are not accepting user request that I want this index data or that index. No, we can return only recently added data. That's it. One thing we have to check here, do we even have data to return it? If you don't have data, how can I return? Very simple, right? So for that, we will check is count less than equal to 0. If it is, that means we don't have data. So we will throw exception. Do we have predefined stack underscore? No. So no worries. What we will do, we will throw normal exception and we will pass message stack underflow or empty. And that's it. And to return actual value, here what we are doing pre-increment on top and then we are storing the value. Instead of that, what we will do here, let me write this clearly. Done. First I am giving whatever index I am storing into top to data to access that indexed location data you can see. After that I am decreasing the value of top. So suppose currently top is 1, then I'll give that 1 to the data and based on that index data will give us this array named data will give us that element whatever we have stored on index 1 and after that it will decrease your top. Very simple. But before returning we have to do one, we have to reduce count also. Complete. And also it, this is big. No logic, no big logic, nothing. Very simple. One thing that we have to do is pick. Suppose user only want to see what is the top element that he has stored. For that, we have pick method where he are just picking into the stack you can say. And here, this check, obviously we have to add. After that, we have to return the data. But here is one catch. We don't have to do this top minus minus. Why? Because we are not deleting the element. Now you may get question that on pop also we are not deleting any element. Whatever element was there on index 1, it is still there, right? Yeah, it is still there. But because we are changing this top pointer, next time whenever someone come and add a new data, it will override your existing data what was there on index 1 and that is how we are saying this is getting deleted indirectly. Whereas in this pick method we are not changing top position, so we are still pointing on index 1 and we are returning the value also to see. Understand? Very simple. If you test this, let me create one object of stack. We will give size 4 and we will do 4, okay, 2. We will do 2 pop operation, sorry, push operation, and we will pass first 1 then 2 then 3. To see is our data even there or not, we will use pick method and also we will pop the data. So first we will pop the data. Okay, no, first we will pick the data, then we will pop. Anyway, output will be same for these two lines because whatever output you will get for this pick, you will get same for this pop because the element is not deleted, it is still there, and this pop will return same recently added variable, and that's why it will be same. So if you guess the output last in first out, last we have added 3, so output should be 3, 3 and 2. Let me run the code. So here we missed the one thing because we have taken list and list internally represent dynamic array. We can't use this plus plus or we can't store data on index level. We can access the data on index level like this, but we can't store the data on index level directly. Either you have to take array over here, pure array, the static one, or else you have to use add method. So because now we have already taken list, so I will use add method directly, but this same syntax will work if you take array over here. There will be no change. So let me take add method instead of the index based accessing for adding, not for removing. For removing, our current logic will work, and because now there is no top plus plus, we have to increase the value of top explicitly. So this is fine, and now let us run the code and boom, see the output what we were expecting. Here we will get 3, here also we will get 3 because in the first operation we have just picked the data, we have not popped the data. So we will get 3 again and after that it will remove 2 and all our operations are working fine, and this is the stack, nothing explicitly complicate things, no. Now if you want to implement the same logic with the help of linked list, that also we can do. So let me remove the code. We will use linked list this time. We will not remove entirely. What we will do, I'll create one linked list class. So to implement with the help of linked list nature, we don't literally need linked list code. We only need node class that we are having in our linked list. If you're confused here, we have already created one video that is dedicated on linked list. Check that out. So there we were having two classes. One is linked list, one is node class. And in linked list, we were having pointer to head node. Same we will do here. Instead of creating entire linked list operations, we will create node class. I'll give more specific name here, linked list node. Let me make it public. If you remember, we have two things in the node class. One, the data. Here we are taking in, so I'll take in directly. And the second thing is the reference to next linked list node itself. This one, because this will be nullable. Why nullable? Pause the video, go back to the linked list video once. You will get very detailed, clear understanding. Whatever data we are passing, I'll assign that here. I'll give getter setter. Perfect. Now come back to the stack class, remove this list and take linked list node. This one is system linked list node. We don't want that. We want our, and here I'll give this as a top directly. Why? Understand. What was the use of this top in the array? Think for a second. This one was helping us to understand what is the recently added element, right? Here what we can do, we can treat this top, this newly added top, as a head pointer that we were having in linked list, and to do push and pop operation, we can do add first and remove first. And if you go with this logic, two things will happen. First, your adding and removing logic will become very easy, because now we have top and you just have to change the top with the new data, that whatever you are adding. And second, it will be efficient. If you go with add last or remove last, you have to traverse from head node to the last node to do manipulation in the tail or last node you are having. Even though you are maintaining tail pointer, that will help you to just add new element or new node. It will not help you to remove the existing last added node. And for that, this add first and remove first will help you a lot. Two things, don't forget this. One is efficiency, second one is you don't have to maintain tail point. So memory wise also, you are reducing the overhead. Do we need this count over here in linked list? Think for a second. In array, it is static. So whatever size you want to have, you have to define initial time itself while creating the array. Whereas linked list is completely dynamic. There is no limitation on the size. Obviously, in real world case, it is depend on your RAM. But if you have very huge RAM available, that is not the same. That case will rarely happen. So for that reason, we don't need count over here. If you want to store the number of elements, then you can use this count, so that you can get to know how many element you are having. But I am saying you don't need count to maintain the size. That is my point over here. Still confused? No problem. Pause the video, scroll the screen, write it down in the comment section. Not a big deal. So we will let this count be as it is. We will maintain the number of nodes that we are having. And for push operation, we can remove this check because there is no need for this. And what we will do, whatever the data user want to add, suppose new linked list node and value, we will store this directly. We will store this temporarily in temp variable, and now we will assign this temp to top. But before that, what we have to do, we have to maintain top. So we will store top into next top temp like this. Perfect, all set. So what we are doing, we created the temp. After that, whatever the current top we are having, doesn't matter is it null or not. If it's null, that means this is the first element. This new temp, this is the first element, and this is last element also. And in linked list, next of last element always point to null. So even though you store top into next, it will be null only. So not a big deal. If it's a second variable, then this top will become the second variable, and this temp that we have just created, this will become the first variable on this line number 12. Because of the line number 12, Visual Studio giving us some suggestion. Let us implement that, and done. For pop operation, obviously here we need to check, is there even data available or not? Obviously. So we can use count variable over here, or we can check null also. If this top is null, that means there is no data. And obviously we have to throw the exception. But count will also work, so not a big deal. And to return the data, now this index based access will not work. What we have to do, we have to use remove first operation. So first, what we will do, we will store current top variable into temp. After that, we will change the position of top from the first element to the second element. Don't get confused here, and if you are still confused, I am highly recommending to go back on single linked list video and done. This is your complete push and pop operation. The only remaining is pick, and that is very simple. Obviously this check will be there. We only have to return top dot data. Done. Nothing else. Now if you want to test this, all things will be same only because we have changed internal logic, not the function names. So we just have to run the code and output should be same. That is 332. Obviously your size will not matter, so we can remove that. But anyway, we are not using this inside. We will remove that. If you see the code, okay, our execution is in progress. Boom, we got the output. See the output 332. What we were expecting, same. And this is all stack. If you are still confused, comment section is all yours. Just pause the video, go little bit down. You don't even have to do a lot of hard work for that. Just go down, write it down. We will cover that into next video. Till that, don't forget to hit subscribe, like and share. This is Mr. Didi signing off. Stay curious, code smart.